Hello everyone, my name is Sam Khosravi and with Nathan Lopez we are two members of the project group named Geoloc. It stands for geolocation, which means to find an estimation of the geographical localization of an object that can be static or moving. Through this presentation we are going to tell you more about our project, first by telling you the context, then by explaining our goal, and then we will conclude.
The mission we were assigned was to set up simulation of a realistic scenario and thus put in place a wall localization architecture in a small room in order to find and track a moving target on a display screen.
Indoor localization has become popular lately in various industrial and consumer applications such as manufacturing chain optimization or location-based access control. What kind of uses for UWB? We can talk about medical uses like wireless vital signs monitoring or of human body or medicine storage monitoring. In communication systems, because it allows a high data rate performance at short range, we can imagine a sensor network in-house, for example. Radar systems, because the short pulse, UWB provide a very fine range resolution and precision distance and positioning measurements.
Localization protocol can be used to track and find people or items to find them faster. This can be time-saving in a wide area. Localization is a growing and promising field in the IoT, which also implies that the security concern for this feature is high. In the case of supply chain supervision, fake position can lead to potential damage or chain immobilization. For medical use, it can help a doctor to gain time in diagnosis, because by looking at the monitored vital signs, the doctor will know where the problem comes from faster. In the case of communication system and radar system, UWB system operate at extremely low power transmission level by dividing the power of the signal across a huge frequency spectrum. The effect upon any frequency is below the acceptable noise floor.
We just talked about some applications of UWB, but in our project we will only focus on the communication and localization aspects. We will focus only on this type of application later on when we will talk about the technical aspects of our project. We decided to work on this topic because we wanted to gain knowledge in the domain of wireless technologies, because when we joined this project we all wanted to keep studying in this kind of domain by continuing a master's degree in wireless technologies and security. The project was also appealing because of its ludic side. For us it was important to get on a project where it's possible to manipulate real stuff.
In order to achieve the project, we need to put in place a gun to plan your work session and also some appointment with your teacher. It's an important part of the project because it helps us to realize how much we had and how much we still have to work to meet the deadline. There is a global view of your Gantt.
Localization systems rely on two types of nodes that we define here as anchor and tags. Anchor are fixed nodes with known positions which perform a distance estimation, also called ranging, on a set of movable tags with unknown positions. In our architecture, tags and anchors are based on the same hardware. The UWB ranging model is a Deca wave used together with a Tensorino 3.2 implementing the Deca library. This library aims to provide a finite state machine-based application programming interface that provides various ranging methods. These ranging methods are all based on time-of-flight protocols, which consist of measuring the travel time of a signal between two nodes.
We have successfully allowed two devices to communicate and send their data to a computer, where we can visualize the calculation of distance between them. It's not very precise, but it's not a big deal actually, as our first concern was to make the experimental setup work. We still didn't achieve your final goal, which is to track a target in a room and draw the path taken by the target on the computer screen.
We still need to work on understanding and using the software that will allow us to draw the path of the target. This software is called Panda 3D, and we still don't know how to allow the computer to combine the data sent by more than one anchor, we will have to pick up the data sent by 3 or 4 anchor and combine them, so the calculation process can happen. This will allow us to calculate the location of the target, and at any moment. Once this is done, it will be possible to draw the path of the target thanks to Panda 3D. And at this point, the project will be done, and if possible, we will focus on improving the accuracy of our system.
We had some trouble to make the project start. We need a lot of time to understand how the material work and how we still process to achieve your mission. Then, when we start, we had a problem to make the system work. We had an appointment with a student in a master degree called Mr. History, which is a student of Mr. Forti, who gave us the complete code to make the new equipment work and use the localization protocol. The main problem with this was that none of us in the group is really comfortable with reading and understanding code, and it's even more difficult when we take the code from someone else. So we had to work a lot of time on this and come back to the student to receive some help.
To sum up, the project is really interesting and it helps us to understand a new type of technology, and it's a great opportunity for us to develop personal skills such as organizational skills or technical skills. We are confident and we work hard because we really want to carry out this project. Our only regrets are that we didn't know that the programming aspects were that strong, because this is our weakness, but we are motivated to overcome this problem. Thank you for your attention.